Hello everyone, this is the pitch presentation of Horus brought to you by Group 1. First of all, let's meet the team, the most valuable asset of the project. The team is composed of both engineers with different backgrounds and non-STEM people. Here's the agenda for today. I am Marianna and I'll introduce you to the first topic. The problem we decided to focus on is blindness. In Italy, it's estimated that over 6 million have visually impaired problems, and among them, 510,000 are completely blind and 2 million have severe visual impairment problem. So, as you can see, the issue is quite spread. Let's dive further into details. We find out that mostly women are affected by visual impairment problems, and the issue is most present as we go up in age. This is basically an overview of the people that we will deal with. As for the market size, we estimated that the market for visually impaired technology is growing thanks to aspects like population aging and growing incidence of genetic disorders. Speaking with numbers, the CAGR of the market is ugly positive, scoring a 8.1% growth for the years 2020-2027. People income is also growing everywhere, even in places like China and India, allowing everyone to buy from the market. But what's already on the market of visually impaired technologies? Of course, staples from the market are the cane, for example. Visually impaired people are actually legally blinded to carry the cane around. Then we have the guided dog and other non-common solutions like the smart cane, which vibrates when you encounter an obstacle, or the smart bracelet, which is similar to the latter. So now the question is, what are we going to add to the market? For the answer to this question, I will leave the floor to my colleague Vincenzo.
Thank you, Marianna. So, while researching the state of the art, we found an affinity with a research project at New York University, and thanks to Professor Torino, we were able to get in touch with them. Their solution is composed of a stereo camera that captures images and depth parameters, an image recognition algorithm which is 𝐬𝐞𝐫𝐵, a backpack containing a PC for processing, an Arduino hardware controlled by MATLAB script, and a belt composed of actuators for haptic feedback. The focus of our solution is on camera glasses. They will eliminate the backpack and remove local processing, which will enhance user comfort, reduce complexity, and send captured images directly into the cloud. Output devices will capture information processed by the cloud. We are talking about a belt, an ear-conducted headset, and a cortical implant, which we will see in details in a moment. 5G connectivity, thanks to the ultra-reliable low latency, will be the key for returning and transferring data from the glasses to the cloud in real time. The 5G cloud will allow for improved image processing, thanks to the artificial intelligence and machine learning and easy-to-scale computing power. It will also reduce battery consumption, reduce the overall cost, and increase the capacity of what people might see. We also thought of a caregiver application that we will see in detail in a moment. For the wearable devices, we thought about different ones. A pair of camera glasses that will always connect to the cloud thanks to the 5G connectivity, equipped with security and encryption protocols that will send the images of the environment surrounding the blind individual. Then there will be a bone-conducted earphone that will provide audio feedback, simply telling the user the direction of the obstacle, but only when it is too close, in order to not disturb the normal hearing. With it, there will be an haptic belt comprised of different actuators placed in different positions. When an obstacle is detected, the actuator vibrating will represent the direction of the obstacle, and the intensity of the vibration will be dependent on the distance. Certain types of cortical implants can partially restore vision by directly stimulating the visual cortex. Deeper cortical stimulation could provide high-resolution images with low power needed, causing little damage. One of the major benefits to this method of artificial vision over any other visual prosthetic is that it bypasses many neurons of the visual pathway that could be damaged, potentially restoring vision to a greater number of blind patients. About the roadmap, the first step will be the shifting of the algorithm on the cloud. Then there will be the implementation of the camera glasses, and then implementation of the different output devices. From a future perspective, we hope to gather more information about the cortical implant technology. And now, for the business part, I will leave the floor to Jean-Michel.
Thank you, Vincenzo. And in order to introduce our business model, we defined the SWOT analysis that helped us to define the guidelines for making our strategic choice. We have always tried to reiterate this valuable tool at every step along the way, And basically, however, we define the strengths of 5G and cloud services as innovation tools capable of benefiting different stakeholders. Then we identify the infrastructural and technical weaknesses so that we could identify the best customer experience. And finally, we try to identify market opportunities and threats that already existed and that we might encounter along the way. Next, we define the business model canvas. That is a valuable tool in order to have a structured and wider approach. As we will see in the following slides in detail, the delivery of the value proposition is a function of the identification of the market segment and the relationship with customers, as well as the activities and resources employed internally and through partners. More specifically, the buyer persona is a segment that includes people between 20 and 70 years old with visual impairments who are looking for innovative solutions to increase their independence and who live in urban areas where 5G connectivity is present. Creating a market funnel was necessary in order to have an estimate of the number of users we will target as a business. And to create that funnel, we made different assumptions. First, we estimated the number of visually impaired people in Italy. Then we segmented that number and found out that over 79% of visually impaired people are over 50. And our target will be 2070, and we matched this information with the results of our closest competitor, that is Orcam. Orcam reached the 0.1% of the available market in the first year of business, so our number of users in the first year based on these assumptions will be 2,000. And now I leave the floor to my colleague Etna.
Hello everyone! To better identify our customer persona, we have created a questionnaire which, by analyzing different aspects of life and habit, has allowed us to better target our product to the end customer. The questionnaire was shared with the help of the National Blind Association of Naples and Perugia. We analyze in particular the habits, the personal data, the experience of mobility, the relationship with technology, the economic situation, and finally some questions dedicated to some elements of the Horus project. The results obtained confirm that the path taken is the right path and allowed us to refine our business plan and identification of our reference target. For the choice of the name of our project, we took inspiration from mythology, as often happened for devices and medical projects. We were inspired by Egyptian mythology and in particular by the god of gaze and ability to see, often represented with the symbol of the eye, Horus. Besides the name, we know that the logo is also one of the brand elements that contribute to the brand value. We started with the structure of the logo, including the name of the project itself, to increase the brand awareness and specifically the brand recognition. We opted for a font that recalled the squared line typical of Egyptian culture, while aiming for a futuristic style that make an immediate mental connection with technology. To break up the continuity and give it a distinctive element, we decided to change the color of the letter O and even modify it by making it like a stylized eye. Finally, we have made a further change to this symbol by inserting a hole. Now, this symbol can potentially refer to three different but central symbols: an eye, a camera, and a vibration. For the choice of colors to build our brand identity, we chose black and white to give a sense of cleanliness, elegance, and seriousness, and the blue, which give a sense of trust and responsibility, but also intelligence and efficiency.
Going into more detail about the value proposition, our strategy is to follow the visually impaired person from the first stages of the experience cycle. In order to involve the customer and make them perceive the potential value of our product, remember that there is currently nothing that offers the same service on the market. We want to offer free consultancy both in concept stores and above all at the offices of the associations of Italian Union of the Blind and Visually Impaired. a player which, as we shall see, will play a key role throughout the customer experience cycle, one of the most solid points of contact between us and our customers. In fact, free tutoring courses will also be held in the UEC offices to learn how to use our device in the best possible way. In our case, however, there will be one of our dedicated specialists also on site, especially to follow potential customers during the 30-day free trial offered. From the moment of purchase, a 2-year warranty will start, including free advice, support and maintenance, as well as unlimited gigabytes of data traffic. In addition, as we'll see later, the dedicated app gives the ability to manage the device and also customize the experience through presets, user-created or downloadable, with the preferred obstacles and point of interest. Seeing this idea from the perspective of a blue ocean strategy, we wanted to focus on one particular principle to determine the actual feasibility of adopting this business model, that is choosing the right strategic sequence. To begin with, it is therefore essential to determine which benefits the customer perceives, both technically and emotionally, compared to other products services on the market. Drawing the matrix of the buyer utility map, which shows both the stages of buyer experience cycle and the utility layers, we have the value proposition seen before. In fact, we can see a focus on customer productivity, convenience, and above all to the customer experience by increasing awareness of the environment surrounding visually impaired people. Then the strategic pricing can be set according to the target costing you want to achieve in order to earn the desired profits. To define the target price, we compared our product to other products that differ in form, function of use and objective. In this case, we have also taken Amplifon as a reference, as a leading device in other type of disability, in order to get an idea of the perception of the value of a device according to the offered services. After establishing the ideal range that the customer would be willing to pay, we established a price of 2,500 euros based also on the degree of legal and resource protection. In order to achieve our desired target costing, we have tried to optimize the supply chain and the relationship with our suppliers. The reduction of the intermediaries between us and the customer through e-commerce and dedicated stores has allowed us to avoid more costs and increase our margins. Working with assembly to order logic has also allowed us to minimize our warehouses costs. In addition, the decision to outsource production has not forced us to invest in a non-key resource and has also allowed us to plan for economies of scale with manufacturers via medium to long-term agreements. And then this is how we plan to bring the device into our users. We plan to establish contracts with producers and assembly factors that will produce our products and will ship them to third-party logistics, which we perform picking and shipping till the houses of our customers. The final price of 2,500 euros can be paid either integrally by the customer, in full or in tranches, or by requesting a reimbursement from the national health system through the 𝐧𝐬𝐴, either by advancing the sum in anticipation of the reimbursement or by waiting for the 𝐧𝐬𝐴 to pay directly when the request is accepted. The doctor in charge must request that the device can be categorized in one of the categories of the nomenclatore tariffario, that is a list of instruments for people with disabilities that can be reimbursed. Specifically, our device can be traced back to two specific categories, which are the magnifier for personal computers and the voice synthesizer, for a total of about 1,649 euros that the end user can save on the purchase if the disability exceeds the 33%.
Thank you. Jean-Michel, I'll start now talking about how we intend to reach our customers. We plan to build different channels, starting from the most conventional ones, like the shops and e-commerce, to the UICI offices. Our channel will be established in different periods of our business. First, we will start selling our product through the associations, which will be provided with trainers to teach clients how to use our products. Then, we will have a call center which clients can call if they have problems in buying or using our device. Then, starting from year third, we will start selling our product online through our e-commerce. It will give us the opportunity to expand our network and start selling in Europe. As for now, we intend to actually expand our business to France and Germany. Last, physical shops will be placed in 2 strategic cities in Italy, Rome and Naples. Then we thought about advertising our product through the strategic CRM and online ads. In these slides, you can now see how we plan to make money. Our stream of revenues will come mostly from the selling of our device through our different channels, as showed in previous slides, and funds that could be public or not. As for the costs, our stream of costs will come from contracts with producers and assembly factories. We plan to establish contracts with some third-party logistics, and some costs from our key activities will certainly come from HR and also from licenses like patents and copyrights. In these slides, you can now see how we plan to make money. Our stream of revenues will come mostly from the selling of our device through our different channels, as showed in previous slides, and funds that could be public or not. As for the costs, our stream of costs will come from contracts with producers and assembly factories. We plan to establish contracts with some third-party logistics, and some costs from our key activities will certainly come from HR and also from licenses like patents and copyrights. In the slides, we can analyze the economical results in number. As you can see, we reached break-even after first year of our business, and also we highlighted some important KPIs like NPV and WACC. Now I leave the stage to my colleague Vincenzo for you to continue with the topic.
Thank you, Marianna. So I will now talk about the digital platform architecture. About the digital platform architecture, we have designed the core interaction both for the application and for the devices. Concerning the application, we opted for an easy and simple architecture, which can be exploited both from the caregiver and the blind person thanks to the voiceover. The user will be provided with some audio tutorials, then he will pair the products, register and find himself on the initial page, which is comprised of 4 main sections. The first section is the home, where the customer can monitor the battery percentages of his devices and set some parameters like the distance and the height of the obstacles. Then the second page will be the settings, where the information about the user is reported. Then we have a page dedicated to the presets. With this, the customer can choose which are the most crucial obstacles that he would like to be notified from. On the last page, we have a section dedicated to the services, where the customer can listen to audio tutorials, call emergency contacts, and if the blind individual does not have a caregiver for whatever reason, we offer the possibility to call for help one of the experts from a dedicated call center. Regarding the device, everything will start from the external world. The camera glasses will capture the video, and after being processed, it will be transmitted to the cloud. The cloud will also receive personal data of the customer from the application. The blue lines are representing the path from the devices and up to the cloud and vice versa. From the cloud, all the data will be processed and elaborated by YOLO and then sent to the devices. Here we can see 2 different paths for the belt and the cortical implant. For the belt, the information will go directly to the devices, while concerning the cortical implant, the path is described by the yellow lines. And now, for the network part, I will leave the floor to Nazanin.
So here is how the future city of our technology will look like. We will cover both indoors and outdoors. For indoors, we will use Wi-Fi 6 technology, and for outdoors, we will use 5G technology. The 𝐬𝐞𝐽𝐽 will be placed on top of the tallest buildings to help covering as more as area possible. Also, we will use the edge cloud instead of directly connecting to the core cloud to reduce the latency for our use case. This is a closer look to the last slide. We will use on-premise cloud and edge cloud and also the core cloud. The information will be gathered from cameras and glasses and then will be sent to the on-premise cloud or edge cloud, and the needed information will be routed to the core cloud. Also, we can see the most important functions that we are using in our technology, and the interfaces which these functions will use to communicate with each other is also noted. We will use entry IWF, non-3GPP internetworking function, to route our indoor traffic gathered by Wi-Fi 6 technology. And here is the connection of backhaul and fronthaul of our network, which is using both fiber and satellite connection. The bandwidth will be split between access and backhaul links. Signaling will be in millimeter wave as it can increase the data rate and allows high resolution streaming video. 𝐬𝐞𝐽 will send the information to the users using very narrow beams, so in order to have a minimum interference level. Now I will leave the floor to my colleague Quirino to talk about the security.
Thank you, Nazanin. Hello everyone, I'm Quirino and I'll show you the security part. When we talk about security, we should start from identify the potential threats which can occur, such as the data branching, that means that a third party can access to our data without permission, the man in the middle, anyone who can sniff our communication and understand what we are saying, and any malicious code like virus, Trojan horse, worm, logic bomb, and ransomware. To face them, we should have clearly in mind the security key points that are confidentiality, to be sure sensitive information is not disclosed, integrity, that assure the data has not been altered, identity authentication, to assure the identity of who interact with the system, source authentication, that, as the name suggests, assure the source is trustable. The security will be delivered downstream on an in-depth study that ensures local protection detection for the use of antivirus and anti-malware software